Hey there, welcome to a new video. In this video we are going to talk about the infamous compressor, one of the most well-known effects in audio production. So compressor just allows us to shape the dynamics of a sound depending on its volume. Okay, so we can expand this thing, and I'll talk about every single parameter. So we have the ratio. Ratio allows us to set how much the sound is being compressed depending on how much it goes above the threshold. So let's say we have our threshold set at -10, okay, and we have our sound peaking 2 dBs over -10. So it's at -8. If we have 2 to 1, we have 2 decibels above. They will be reduced down to 1. So we will have the sound outputting at -9 dB. Okay, that's how it works. If we have 4 to 1 and the sound is peaking at -6 dBs, it will peak back to -9. Is 4 to 1. Okay, it's a sort of division value. If we have the sound peak at -2, it will be compressed down to let me do some quick maths, -8. So it's just going to be divided by 4. Then we have the attack time, how quick the compressor, the gain reduction engages. So if we have it at 0 milliseconds, it will start instantly with just 0.01 milliseconds of delay. If we set it at 25 milliseconds and the signal goes over the threshold, it will take 25 milliseconds for the gain reduction to engage. So we can let some transients pass through. Then we have the release. The release engages as soon as the sound comes below the threshold. So if our sound is peaking over and then it goes below, the release starts engaging, and this is how quick the gain reduction comes back to 0. So it's not compressing anymore. Also we have the auto release, which it simply turns on some algorithms and for the release, and it will keep changing the release time depending on what's being compressed. Then we have the threshold, which is one of the most important settings. Probably is the most important parameter, because it allows us to catch the audio we want to compress, the portion of audio we want to compress. Here we have the gain reduction visualizer. So just to show you how it looks. This is the amount of compression that it's being applied in real time. Then we have the output, and we can turn it down if it's too loud due to the makeup or any other reason. We can turn it up if we just compressed the sound too much. Then we have these 3 views. We have this one, then we have this one. Okay, let's see how it looks. We have this dot that shows us the peak value and how much is being compressed. So if we have it at 1, this is the actual peak, the input signal. If we turn the ratio up, we will see the peak of the output signal. Then we have the knee that allows us to smooth out the excursion of of compression, how much, how soft or how hard it engages. So if we have it at 0, we will have black or white. Okay, if we turn it up, the compression won't start at minus 24.7 dBs, but earlier, and it goes more and more and more and more, and then here we have the full 7.88 ratio compression. Then we have the look ahead. The look ahead allows the compressor to look in the future. Okay, it's simply a buffer thing that delays the whole playback thing a bit, but it introduces some latency, but it allows the compressor to engage as fast as possible because it's previewing what is coming into it. Then we have the envelope. The envelope, I can show you it here. So let's do some compression. Let's try drum sample. We will have some fast claps going on, but it's for the knowledge. So this is the logarithmic thing. This is the linear thing. It's the release behaving in different ways. Then in this third view we can see the envelope. We can also see the output. Here we can see the gain reduction, and here the output. So we can see how the sound is being shaped. Okay, and in this last part on the far right we have the makeup volume that automatically compensate the output level as the threshold and the ratio values change. So use this carefully. I usually prefer to turn it off by default. Then we have peak mode, RMS, and expand. Peak mode sets the compressor so it responds to short peaks within a signal. So it's really useful for compressing short sounds like drums, clicks, or any other thing that has really high and short spikes. Maybe a plucked guitar or a short pluck, you can go with peak. This is not a golden rule, but it's just a rule of thumb. Then we have RMS, which is root mean square mode, and the compressor is less sensitive to short peaks and responds more slowly. So I suggest to use this for melodies if we want to compress them to make more glued and not to catch the peaks. Okay, then we have the expand that just turns the compressor into an expander. We have the ratio that is changing from 1:1 to 1:2. So we have this one. If we turn up, we can see that the gain reduction is not a gain reduction anymore, but it's more it's a gain expansion. So this is it. We have a dry wet, and then we have all the sidechain module. We have this sidechain here. We can take the audio input from another thing. So let's make a new track. Okay, we have audio input from let's say audio, which is the first one. Of course, you have to rename your tracks properly, because when you want to set sidechain, this is going to be painful if you don't do it. Okay, and we can also choose the input from pre-FX, post-FX, or post-mixer. Pre-FX means that it's going to sidechain to this actual sample and not what is going through. If we do post effects, it's going to compress it depending on what's coming out of the last effect, so the compressor in this case, and post mixer it's post the fader, so post this one, and also depending on the volume it's been set. So now let's just see how to do this sidechain. Okay, post effects, just let's bring it back to peak mode. We can see that it's being compressed. We have also the mix. That adjusts the balance between external and internal signal used for triggering the device. Then we have the sidechain listen. We can listen what is sidechaining to. And then we have the sidechain EQ. So if we turn on this module with the sidechain, we are EQing the sidechain input. So we are sidechaining to this portion of the clap. We also have a Q, and we have the filter types. Let's say you have a kick and you want to compress, you want to sidechain any sound only by triggering it with the click, with the transient. We can do it this way. If we turn off this sidechain, okay, so let's do it on this other sound. You can see that if we turn the threshold all the way down, as I turn the frequency down, we have more frequencies that are pushing the compressor. Turn it all the way up, we have less gain reduction. This is the sidechain filter, and simply we have the high frequencies or the selected frequency depending on how you set it, that are triggering the compressor and are affecting the whole sound. So this is not filtering the actual sound, this is just filtering what is triggering the compressor. Okay, so let's say we just put it to 50%. We can hear the full sound, and the full sound being compressed only by what's above 15 kilohertz. So this is it for the compressor. Hope you understand everything, and see you in the next video.